Welcome. We left the last video with a parser capable of parsing single assignments, and in this one we are going to add type inference to our compiler. What we are really trying to do is to have this function, typer infer types, that is going to infer any missing types in our statements and expressions. As usual, for that we can begin by creating a new file. We can call it typer.h and add all of the boilerplate code as well as some includes that I know that I'm going to need. And inside the main file we can already include it by adding it between the parser and the writer, since this stage is after parsing and before we write it to C file. So we can begin by writing this typer infer types function. It is actually quite simple. It just loops through all of the function definitions inside the program and then calls typer sugar function definition assignments. The typer sugar function definition assignments is basically going to infer the type of the expressions we are using inside the assignments, as well as add the variable declarations to the beginning of the function body. We can begin by asserting that the AST was passed to us is actually a function definition, and then simply extracting the statements into a variable. After that, we can create a loop through all of the statements, as well as this new variable called new statements. This is actually not needed right now, but since we need it in the multi-assignment compilation, decided to add it right now so we don't need to modify the code later. Inside the loop, we can extract the statement into a variable, and then we can check if the statement is a AST variable assignment. If it is a variable assignment, then we need to extract the variable declaration from the single assignment, append it to the function definition variable declarations, and append the current statement to the new statements variable. If that's not the case, then we really don't need to do anything. We just need to append the current statement to the new statements variable. And finally, at the end of the loop, we just need to replace the current function definition statements by the new statements. We now need to define this typer declaration from single assignment function. So we can begin this function by asserting that the AST that was passed to us is a function definition. We extract the parameters of the function definition. We extract the current declarations of the function definition. After that, we assert that the assignment that was passed to us is actually a variable assignment. We extract the expression from the assignment, and we extract the declaration name from the variable assignment. Now we need to handle all of the cases of the expression kind. In this case, if the expression is a string, we need to return a new variable declaration with the declaration name we extracted, and for now an SV of type *pointer. Noting that in the future the primitive type for our language for a string is actually going to be a struct. If the current expression kind is a AST integer, then we can create a new variable declaration with the provided name and the type int. But if it is the case of AST variable, then we need to extract the variable name. And now we need to find the definition of this variable. We can begin by searching inside the parameters. We can simply use SV equals to check if the parameter name is equal to the variable name. And if that's the case, we can just return a new AST variable declaration with the type of the parameter we found. If we didn't find anything inside the parameters, then we need to search inside the variable declarations of the function definition. And in this case, we do a similar thing. We just search by the name, and if the name is the same, we return the declaration type. If we didn't find anything inside the function parameters or the function declarations, then we need to return an error, as well as for the default case, we also can return an error. If you have been following this series of videos, you must be suspecting this AST variable, because we actually don't have this node. So let's quickly add it. So we can just add it as AST variable to our AST kinds. And the value of such variable is just going to be a string view with a variable name. We add the constructors. And in this case, the variable is just going to be parsed as an expression. And to do that, we can add a new condition to check if the current token is a token ID. And if that's the case, we can just create a new AST variable from tokens. As you may expect, we need to add it to the dump AST function. We are just printing the variable name. And finally, if we parse the current code, you can see that we have a function definition main without parameters, without return types, with one variable declaration of the variable a of type int. In this case, a was inferred as integer because the statement of the variable assignment to a as an expression integer 42. If we try to parse a more complex and interesting problem, in this case the function f with one parameter, two return types, two variable declarations and two variable assignments, and one return statement, you can see that we have a function definition f with one parameter of type float, two return types of int. Then we have two variable declarations that were added by the compiler, one for the variable n of type float and one for the variable m of type float. Note that we were able to infer the type of these variables by looking at the parameters of the function. Then we have three statements. The first one is a variable assignment of x to n. Then we have an assignment of x to m. And finally, we have the return statement that contains n and m, two variables. And after that, we have the function definition main that we had previously. As you can see, we are now being able to parse quite complex programs in relation to what we had just a few episodes ago. And this is how you desugar single variable assignments in C. In the next video, we'll be compiling these single assignments.